Hello everyone. Today let's solve the Leetcode problem number 55, jump game. So what the question says, you are given an integer array nums. You are initially positioned at the array's first index. So and each element in the array represents your maximum jump length at that position. So we are initially positioned at the array's first index, right? So and each element in the array represents your maximum jump length at that position they have given. So we have to return true if we can reach the last index or false otherwise. They have clearly mentioned we have to return true if we can reach the last index from the first, right? Or the false otherwise. So if we are not able to reach the last index, we have to return false. So in the example 1, they have given 2, 3, 1, 1, 4 and we have got the output true. Why the output is true? Jump 1 step from index 0 to 1. Then 3 steps to the last index, here to here, then here, or we can consider from here as well, here to here, then 3 steps, nothing but 2. We can iterate from here or we can iterate from the last index, last to first or first to last. So here jump 1 step from index 0 to 1 they have given, then 3 steps to the last index. So we can and the output is, so that's the reason we have got the output true. So here we cannot, why 3 to 1, 0, 4 they have given. Here the output is false. Why? You will always arrive at index 3. Nothing but this one, 0, no matter what. So its maximum jump length is 0, which makes it impossible to reach the last index. So we cannot reach the last index because we have, at any cost, we will be reaching the index 3. Nothing but the value we are having is 0. So we cannot reach the last index. So the output they have given is false. The first index, the first example we got true because we can. And the second example we got is false. So let's try to write the code. And then I'll explain this one by taking example 1. So you can check for the example 2 in the similar way. So first what I'll do, let's initialize the last as the last index of the array. So let me give last equals length of the nums minus 1. Nothing but the last index we are considering here. This will be 4, right? So next we will traverse the array backwards starting from the last index. We are traversing the array backwards from the last index, nothing but we are considering 4 first. Here we are traversing from backwards to from backwards, right? Starting from the 4. So let me consider the for loop. So I'll just give let I equals length of the nums. So I greater than or equal to 0, I. So this is simple. Next we will check if the current index I can reach or go beyond the last index. So if the current index can reach the I, nothing but here from this one to this one, right? The last index will be, we are traversing backwards. So from 4 we have to jump to 2, right? This will be last index when we are traversing from the backwards. So we will check if the current index I can reach or go beyond the last index. If it can, then we will update the last to the current index I. Nothing but we will update this one in this example to the last index I, right? How can we write that one? I'll just consider if a statement I plus iterated value of the nums. If it is greater than or equal to last, so what we will do, then I'll just give last equals I. Nothing but if it can, we will update the last to the current index I. So that's what we are doing, right? So then the last step is, if after the loop last is at the index 0, nothing but here. So we are again I'm telling we are traversing backwards in the array. So this will be the 0th index for us first. So the first index this will be, and it has to reach the index 0, right? So if we have reached the index 0, then it means we can jump to the last index from the start. Considering 4 to 2, we can jump from 4 to 2, right? So what we will check, we will just check the return whether last equals 0, nothing but the 0th index. So I hope this is clear. So let me hit the submit. So let's wait for some time. So this works absolutely correct. So what I'll do, let's consider the example 1 and let's see how we implement the same thing, right? So this works correct or not. So you can check for the example 2 in the similar So initially we will consider this example, nums 2, 3, 1, 1, 4. So the initial last position is 4. This one will come. The last position is 4, right? Nums dot length minus 1 we have given. The last position is 4. We will iteration 1. I will be nothing but 4. We will check nums of I, this one, nums of I greater than or equal to last. Nothing but I plus nums of I equals 4 plus 4. Here, this step we are carrying on, right? I plus nums of I, which is greater than or equal to last. So first it will be like 4 plus 4 here. 4 plus 4. I plus nums of I is nothing but 4 plus 4. We'll get I is 4 and nums of I is also 4. 4 plus 4 is nothing but 8, which is greater than or equal to last here. This one, which is greater than, 8 is greater than or equal to 4, right? Nothing but greater than 4. So since it is true, we'll update the last to I equals 4. So now the I in the first step we got I equals 4, right? First step we got I equals 4. In the second iteration, what we will do, we will come to the index 3. This one, index 3, we have the value 1. So I plus nums I, again we will come to this this line, I plus nums of I, nothing but 3 plus 1. I will be now 3, index is 3 and nums of I is 1, the value is 1. 3 plus 1 is 4, which is equal to the last 4, greater than or equal to last is 4, 4 is equal to 4. So since it is true, we will update the last to I equals 3. Now I will be equal to 3, right? Second step, I we got 3. So now let's come to the index, this one, index 2. I equals 2. So I plus nums of I is nothing but index is 2. 2 plus 1. We have the value 1, right? For the second index here. We can clearly see here, right? We have considered 4 and 1. Now the value is 1. So 2 plus 1 is nothing but 3, which is equal to the last 3. So since this is true, we will update the last to I equals 2. Now in the third step, we got I equals 2, right? So next, the iteration 4, we'll consider the index 1, nothing but the value 3. This one we are considering, right? So I plus nums of I, again we'll come to this line. So I plus nums of I is nothing but 1 plus 3, 4, which is greater than the last 2, which is greater than the last 2. Now since this is true, we'll update the last to I equals 1. In the fourth step, I we got is 1. So this is simple to understand, right? Now I is 1 at the fourth step. We'll check for the last iteration, nothing but the iteration 5. So the value is 2 and the I equals 0. We'll check if I plus nums I, this one, again we'll come to this step, I plus nums I, nothing but 0 plus 2 is 2, which is greater than or equal to last equals 1, right? The last is 1 and which is the 2 is greater than 1. So since this is true, we will update the last to I equals 0. Nothing but in the fifth iteration, I we got is 0. So new last position is 0. The I is 0 at the this one, the last iteration, the I will be 0. Final check what we are doing. After the loop, last is 0. We can clearly see here, after the loop at the last iteration, I is 0. What it indicates, meaning that we can reach the last index starting from the first index. We have started from 4 and now we have reached the 2. So what we will do, we will the function is returning true. We are returning true. From the 4 we have returned to 0. So this is the last iteration and we have reached the 0th index. So the function is returning true. This indicates that it's possible to jump to the last index. Sorry. So what we have done in simple terms, first we started from the last index and we moved backwards from 4 to 2, right? So we kept updating the last position to the current index. If that index can reach the last, then we have ended up at index 0 for last. It means that we can reach the start of the index, right? So we have reached 2 here, nothing but the index 0. So the function is returning true. So this works absolutely correct. So what will be the time complexity and the space complexity? So the overall time complexity would be big O of n. Why the overall time complexity is big O of n? Because we are, the loop runs once throughout the array, this one, right? The loop runs once through the array, making it linear in the time relative to the size of the input array nums, this one. So in simple terms, we are making use of the loop only once, right? So this one will lead to the overall time complexity big of n. What will be the space complexity? The space complexity would be big of 1. Why? The space complexity would be big of 1 because the algorithm uses a constant amount of space regardless of the input size. So the overall space complexity would be big of 1. So the time complexity would be big of n and the space complexity would be big of 1. Let me comment this one. So yeah, this one, let me hit the submit again. So this works absolutely correct. So this is it. Thanks for watching, guys.